Hi, I'm Tracy from Gaia Resources and I'll be taking you through Exercise 1. QGIS is an open source geographic information system, or GIS, that allows people to make maps and view various forms of geographic information. During the course you will learn tasks to import, interrogate, edit, create, visualize, geoprocess and export data. In this video we'll be focusing on familiarizing you with QGIS and the basics, such as how to save your data correctly, add data, and so on. If you're already familiar with QGIS, you may wish to skip ahead to the folder structure or even move ahead to the next video. You may notice there are two types of QGIS applications installed on your machine. The QGIS browser lets you look at a dataset, while QGIS Desktop allows you to manipulate and map datasets. This is the one we'll be using. Open the QGIS Desktop program. We're using version 2.18. Workspaces are a placeholder for your data. They allow you to visualize, color, label, filter, and modify the data held within them. QGIS comes with a variety of tools to analyze, process, and review your data. Your workspace is customizable, so it may look a little different to mine. Up the top we have the menu bar, which contains your workspace properties, settings, tools, plugins, and other details about your workspace. Below this and down the left are the toolbars, which contain a bunch of icons for different commands. If you hover over buttons in the menu and toolbars, you'll get a preview of what they are. These can be added and removed as required, so your icons may look a little different to mine. This top window is your file browser, and below that is your layers panel, which is a table of contents for the layers within your project. It's empty right now, but as we add to the project it will fill up. This large window here is your map canvas. Down the bottom we have the info bar, which shows information about the current map extent shown in the map canvas. Here you've got the exact coordinates of your cursor. If you move your cursor around, you'll see that these change. Then you've got your scale, magnifier, rotation, and coordinate reference system. This is an important one, and we've talked about it more in a prerequisite video. We've given you a bunch of data for this training in a folder called Trainee Documents, and if you look at your pre-created folders, you'll see that they're called 01 Training Data and 02 Training Outputs, and within these are a bunch of subfolders to keep our data organised. Click on Project, Save As in the menu bar. Navigate to Training Outputs, Workspaces. Give the workspace a name, we'll call this Exercise 1, and click Save. Click the Add Vector Layer icon. Under Source, click Browse. This will take you to your File Explorer. Open the folder 01 Training Data. Remember, this is the folder we've set up to store all of your input data. Open 01 Shapefiles. We've put a folder in here called Bremer Bay, which has a series of datasets in it. In File Explorer, Your Folders, click on the drop-down list on the bottom right-hand side. This gives a list of all available format options QGIS can read. Select Esri Shapefiles.shp. Select 5012 mainlands.shp and click Open. The layer will appear in the table of contents and its visual representation in the map canvas on the right. You can turn it on and off by checking this box. If you can't see the layer in the map canvas, just make sure that this box is checked. If you still can't see it, right-click the 5012 mainlands.shp layer and click Zoom to Layer. QGIS randomly assigns colours to the layers you add, so your data may look different to mine. You can change the way each layer looks. More on that later. If we go to our File Explorer, you'll see each shapefile has 4 extensions. Shapefiles can comprise up to 15 individual files, but these are the most common. We use the .shp file in QGIS, which is the features geometry. Then you have .dbf, which is the features attributes, .prj, its projection, and .sbn, sbx, or shx, which are the spatial indexes. Next we're going to add some more layers to our workspace. Go to Layer, Add Vector Layer, or use the icon in the toolbar. Under Source, click Browse, which takes you to your File Explorer. So let's go into that Bremer Bay folder, Data, Shapefiles, Bremer Bay. Now hold your Control key and click the following. Make sure you select the ones with .shp extensions: islands, lakes, native vegetation areas, populated places, reserves, and roads. and click Open and Open again. All those layers will appear in your table of contents and should all be turned on. You can play around with the layer order by clicking on a layer and dragging it up or down, then releasing. Now we can only see the mainland layer because it's covering everything else. So let's reorder our layers as follows. Populated places on top, then reserves, native vegetation areas, roads, lakes, islands, and mainlands. Next we're going to look at metadata. This is information about the layer and it helps us understand where the layer came from, when it was created and modified, what methods were used to generate it, who created it, and who to talk to for more information. Metadata can give you a better understanding of how useful it might be for your work, or if it's the most up-to-date version of that data. It also comes in many different formats, such as text or XML files. Our Bremer Bay data is from Geoscience Australia. If you go to your File Explorer, under the Bremer Bay folder, there's a metadata folder. Open the GA PDF and have a bit of a read of Appendix D metadata and see if you can find the data currency beginning date. Pause the video here if you need to. Did you find it? Okay, back to QGIS. Metadata can also be stored within the data. Right-click on a layer and click Properties, then find the Metadata tab. Our data is from Geoscience Australia and they have a separate metadata document which you just read, so there's not much info in here other than the automated data, but many layers will store very useful information in here. Click Cancel. Okay, let's rename our layers to something more useful to us. Right-click your layer and click Rename. We're going to rename the Populated Places layer to Towns. We'll give these other layers some simplified names too. Note that changing the names of the layers only changes them in this workspace. Your original vector files will keep their shapefile name. If you hover over the layer in the table of contents, it will show you its folder directory and you can see the original name is retained. Raster layers can represent a number of useful features such as satellite imagery, elevation, temperature, and so on. They're grids where each cell has a common variable. For example, you may have a raster layer showing groundwater depth and each cell will have a value for that attribute. Images and rasters can be added to your workspace if they're georeferenced, meaning their extents are referenced spatially. To add a raster layer, click on this icon, or go to Layers, Add Raster Layer. We're going to navigate to our data folder once again, then go to Images, and select this file here, which is an image showing the topography of Australia. Move it above your other layers in the table of contents and make sure it's turned on. In this toolbar, you've got a bunch of icons which you can use to move around your map. You've got your pan button for clicking and dragging the map, zoom in, zoom out, and so forth. You can use your mouse wheel to zoom in and out, which is faster than clicking on the icons each time. This icon zooms out to the full extent of the map. This icon zooms back to your last extent, which is really handy. For the next few exercises, we won't be using the topographic raster layer, so let's deactivate it to speed things up a bit. We can add extra functionality to QGIS by adding plugins, which are extensions of the core product. One useful plugin is Open Layers, which allows you to view online imagery like street maps and satellite imagery. We're going to add that now. In the menu bar, click on Plugins, Manage and Install Plugins. Under the Install tab, review which plugins you already have. Sometimes this comes pre-installed, so just ensure it's checked, but if not, click on the All tab, search for the plugin called Open Layers plugin and select it, click Install Plugin, and click Close. Now you can use this plugin to add Google Maps as a layer to your table of contents. Click Web, hover over Open Layers plugin, and you'll get a list of options. Hover over Google Maps and select Google Satellite. Drag this above the Islands layer. This may take a while to load depending on your internet connection. You can now see some of your layers on top of the Google Satellite imagery. Have a play with this and zoom in on an area of interest. Once you've had a play, we're going to remove it as we don't need it for this project. To remove a layer, just right-click on it and select Remove, then OK. Just as a side note, if you ever start a project and go to add Open Layers imagery and you get an error message, Add a vector layer first, then your open layer. Then right-click on your vector layer and click Zoom to Layer. The info bar at the bottom of your workspace shows your general information and offers some tools for your workspace. These include the coordinate location of your cursor, the scale of your data in the map canvas, the magnifier tool to zoom in statically, the rotation tool to rotate your map view, and the workspace CRS ID. If the CRS is greyed out, you don't have Enable on the Fly CRS transformation activated. You can change the CRS ID from here using this icon. So, if you hover over the Bremer Bay town site, you'll see the coordinates of the site in the info bar. Are these in lat long or easting and northing? If you click on the scale arrow, you'll see a range of scale drop-down values. The 1 represents the map canvas and the larger number is reality. So 1 to 1000 means 1 unit on the map canvas is 1000 units in reality. What scale from the drop-down list allows you to zoom in closest to the data? Remember, the larger number represents units in real life. If we select 1 to 500,000, 1 unit on the map now represents 500,000 units in real life, so you're squeezing more geographic extent into 1 unit. In other words, you zoomed out further. To check which CRS your data is in, right-click the layer and go to Properties, then General. You'll find the CRS information listed here under Coordinate Reference System. Your workspace also has a CRS, which you can find by clicking Project, Project Properties, CRS. And here's your project CRS down the bottom. At the top of the page, there's a checkbox named Enable on the Fly CRS Transformation. You want to make sure this is activated because it allows you to allocate a CRS for the workspace. This means that any layer in your workspace with a different CRS will still overlay correctly. Now we want to make sure any new data we create is in the right CRS, and to do this we need to format the workspace. In the menu bar, go to Settings, Options, CRS. Under Default CRS for new projects, ensure that Automatically Enable on-the-fly reprojection if layers have a different CRS is checked. Ensure that Prompt for CRS is selected. This will give us the option of setting the CRS for any data instead of the workspace automatically selecting one for you. Click OK. Now, since we've been viewing a Google imagery layer, this often overrides all other projections and doesn't revert even after removing the layer. If you look down in your info bar, you'll see that the coordinates don't look like your typical lat-long values for the area we're working in. Once the imagery is removed, we have to reset the workspace to the CRS that you're working in. Go to Project, Project Properties, click the CRS tab, type in the filter text box GDA94, select the top result with EPSG4283 and click OK. Your workspace will now show latitude and longitude coordinates in the info bar. You can also set your own keyboard shortcuts. Click Settings, Configure Shortcuts. Click the action you'd like to update, click Change. When input appears, type the action you would like the shortcut to be, such as Alt-D, and click Close. You can access additional help and information on the QGIS functions and tools by clicking on Help, Help Contents, and searching for an issue. QGIS has the option to render data over your various CPU cores, which makes your data load faster. Since some of the data layers you work with could be very large, and you may find yourself adding and removing data layers frequently, it might make sense to set QGIS to render them in parallel to make the application more efficient. To turn on this rendering option, in your menu bar, click Settings, Options. Under Rendering, check Render Layers in Parallel using many CPU cores, and click OK. Save and close your workspace. That's the end of exercise 1. Hopefully you're now familiar with the QGIS workspace and basic functions. Head to Exercise 2 to look at data structure and review. Thanks for watching.